Hello everyone, and welcome to a new video in which we'll be solving an interesting example, which is motor startup and shutdown sequence. Now the reason I'm going with this example is because I have received several requests to do so from our online friends. Now I have to warn you that this example or this video is longer from any earlier video that I've done before, and to be honest with you, I'm not a big fan of creating long videos, but I had to do so in this specific example because not only I'm providing you with a solution of this example, but also I would like to share with you some of the teaching techniques I usually follow with my students, and also to provide you with some programming techniques as well. So in this example, I would be introducing to you some of the concept of using internal PLC memory tag, these tags that do not actually have addresses that's going to tie them to actual inputs and outputs. And you will see how using these tags increase the flexibility of your program. Also, for this specific example, I'm not going to get it to a point where it's 100% functional and optimal. I would get it to a point where there are a couple of glitches that I would like for all of us to use the comment section to discuss them and figure out the solution for them. The reason I'm doing this is because I do not want my channel to be a room for simply providing you with a solution. I want it to be a channel for you to learn and to develop your own techniques and skills and tools to develop your own solutions. That's the main purpose of this channel. That's the main purpose of going through these examples together. And that's one of the techniques I follow with some of you folks who send me their emails with some problems that I'm having in these examples or their own problems. I always ask them to come up with their own solution, and all what I need to do is tune their work and guide them for them to continue and complete their own version of the solution. I never dictate my way for you to do it. So remember this, and the solution we are following this video is not necessarily the optimal one, and definitely it's not the only correct version. You can always build multiple correct versions for any problem. So having this in mind, let's go ahead and see the solution of this problem, motor startup and shutdown sequence. And towards the end, do not forget to look into the glitches and see how you can solve them.
The example we're solving today is motor start and shutdown sequence. And like any other problem that we have attempted before, the best approach to solve this problem is to break it into minor requirements and solve each one of these requirements by itself. And we are going to discover at the end that the cumulative solution for each one of these requirements will be nothing but the overall solution for this whole problem. So we're going to start with the startup sequence, but before we start, please be aware that we have solved exactly the same example for the startup sequence by itself in video LD16, motor startup sequence with interlock. But right now, because this example involves both startup and shutdown, we will be doing the startup again, and we are going to add to it the shutdown sequence as well. So let's start with the startup sequence. The first requirement, it says oil motor will start once start, which is normally open push button switch, is pressed. So pressing the start, this will get the oil motor to be on right away. I will be using the highlighting just to denote that I'm pressing a switch or a motor is actually on right now. That's the first requirement. Going to number 2, the oil motor needs to remain on even after the start is released. So start is a normally push button switch. Eventually we will let go. The oil motor has to remain on. By doing the logic will take care of this. Moving along to the requirement number 3, it says 10 seconds after oil motor is on, the main motor will start. In other words, there is no switch that needs to be pressed in order to get the main motor to be energized. Main motor is time dependent, so after 10 seconds from oil motor being on, automatically the main motor will be energized and it will be on. Similarly, we'll go to the final requirement, again the third motor in our list of motors in this startup sequence, which is the auxiliary motor. This one is time dependent on the second motor, main motor. So main motor is on right now. Another timer will kick in for 5 seconds, and at the end of the 5 seconds the auxiliary motor will be energized. So right now the startup sequence is completed, and as you all can see, all of them are highlighted, denoting that our startup sequence has been completed. Why are we using the stop? The stop is mainly to stop any running motor that's running during any phase of this startup sequence. So if we have the oil motor by itself on, hitting the stop, this will turn the oil motor off. If we have oil motor and main motor, again hitting the stop will turn off both motors. If the three motors is on, pressing the stop will kill all of them. It doesn't state over here, but in our examples we are always going with for the stop as normally closed push button switch. Over here, to save some space, it's not written down, but I'm saying it out loud over here. So as you can see in this example, it involves 3 inputs: start, stop, shutdown, and 3 outputs: oil motor, main motor, and auxiliary motor. All of these are discrete IOs, and the bit instructions that we have covered so far are nothing but XICs: examine if closed, examine if open, XIOs, and OTEs, to refer to these IOs in our coding. And because we have timer factors as well, right, this means that we need to integrate timers in our solution. How many timers? Going back to the requirements, we have 10 seconds for requirement number 3, we have 5 seconds for requirement number 4. This means that we need to integrate 2 timers into our solution. And remember, folks, the type of timers that we have covered in RSLogix or Study 5000: timer on delay TON, timer off delay TOF, or retentive timer on delay. So which one to use among these 3? The simplest one is the timer on delay. Why is this? Because remember that TOF works when an output turns off. Once an output is de-energized, that's when the timer kicks in, and we do not have this requirement right now. Retentive timer, we can build this solution, and if you remember in video 16, we have solved that problem using TON and RTO. But again, simplicity states, because there is no requirement that requires holding or maintaining the accumulator value of the timer, then there is no need for us to go with the RTO. So that's why we will be using the TON for the solution. But if your mindset tells you to go with the RTO, by all means, go for it. And if you have any solution, please leave any comment in the comment section. So this will conclude the startup sequence. Right now, let's move along to explain the shutdown sequence. But I do recommend, before you attempt to solve or build your solution for the shutdown sequence, please make sure that you are aware, you are capable of building the solution for the startup sequence. Make sure you build it completely based on these requirements, download it to your PLC, or download it, run it, and test it. Make sure all of these requirements are fulfilled before attempting the shutdown sequence. This will significantly helps you in terms of understanding the problem and troubleshooting any errors that you came across. So let's move along to the shutdown sequence. And now we're back with the solution for the startup sequence. And the reason I did not go through the steps to build the solution is because we have already done this in video number 16, and all that the folks need to do is just check that video. I have the link on the top in order to see the steps to build the solution. But before we proceed to add the steps for the shutdown sequence, I'm going to follow my recommendations in terms of running this program, making sure that the startup sequence works fine before we add the necessary code for the shutdown sequence. So if you can see right now, we are in the run mode. It's a green color all over the place. We have the first rank for oil motor, main motor, and auxiliary motor. And to the left, I'm going to show you how to run this thing. So if you press the start, it goes from 0 to 1. If you look, the oil motor is on, timer 1 is running. In the meantime, main motor and auxiliary motor both are off. At the end of the 10 seconds, the main motor is on, and still the auxiliary motor waiting for the timer 2, and now auxiliary motor is on. So if you see, the oil motor was dependent on the start, and both main motor and auxiliary motors were time dependent. The first one on oil motor, and the auxiliary was dependent on the main motor. Anytime we press the stop is normally closed. That's why it reads 1 in the PLC memory, you press it, it goes to 0, and it kills all 3 motors all at once. Okay, so one more time, if we start this thing, oil motor is on, T1 is on. Remember, the job of the stop is to kill any running motor anytime during the startup sequence. We don't have to have all of them on. So right now auxiliary motor is off, but if you hit the stop, it kills everything. And that's the purpose of the stop. So this solution for the startup sequence works fine. And right now we can go ahead and add the necessary solution to fulfill the requirements for the shutdown. Let's have a close look at the requirements that make up the shutdown sequence. Before we start, if you folks look at the bottom of the screen, you will see that all 3 motors are being highlighted, just to remind us that at the end of the startup sequence, all 3 motors will be energized, and that's an essential requirement that is needed among the list of requirements to make up the shutdown sequence. To initiate the shutdown, all of the 3 motors have to be on. If one of them is not energized, pressing the shutdown will not initiate the shutdown sequence. So in other words, if the oil motor by itself is on, hitting the shutdown will do nothing. The startup sequence needs to continue building up. If both oil motor and main motor are on, but the auxiliary is not on, similarly, pressing the shutdown will not stop the startup sequence. The startup sequence needs to be completed all the way to the end, of course if the stop is not pressed, and all 3 motors are on. That's when only if you press the shutdown, that's when the shutdown sequence will initiate according to the following requirements. So the first requirement is hitting the shutdown. This will kill the auxiliary motor right away, automatically. So think of the shutdown as if it's acting as a stop only for the auxiliary motor, not for the first 2 oil and main motor. Now, similar to the startup sequence, the main motor will be time dependent on the auxiliary motor. So once the auxiliary motor is off, 10 seconds later, that's going to kill the main motor. Now, the third and final motor, which is the oil motor right now, will be time dependent on the main motor. So main motor is off, the second timer will kick in for 5 seconds. At the end of the 5 seconds, that's going to automatically kill the oil motor. So here you go. If you folks notice, it's a very similar concept compared to the startup. However, this is working on the other direction in terms of building the shutdown sequence. And again, we have 3 inputs, we have 3 outputs, so XICs and XIOs and OTEs for these discrete IOs, and similar discussion to what we have in the startup sequence. We need to integrate 2 more timers to build the shutdown sequence. How many timers? We said 2 because we have 10 and 5 seconds to fulfill the second and the third requirements. Similar analysis, TON, TOF, or RTO. For simplicity reasons, we will be using the TON to fulfill the solution for the shutdown sequence. Remember, folks, that the stop input at any time it's pressed during the startup sequence or the shutdown sequence, that will act as an ESD, emergency shutdown. It will kill all 3 motors right away. So we need to look into adding this solution for this to integrate the stop to kill any running motor even during the shutdown sequence. So in other words, our solution need to make sure not only if we have initiated the shutdown sequence then the stop will not work. No, the stop needs to be integrated during any phase of the startup or the shutdown sequence. So right now we have broken down the requirements for both the startup and the shutdown sequence, and I'm expecting right now, since we are explaining the shutdown sequence, that you folks have completed building the code for the startup. Right now go ahead and add the necessary code for the shutdown sequence, and we will look into my solution for this. And remember, there is not only one way for the solution, there is I would say infinite of ways, infinite of use of timers, arrangements, and to build these solutions. So follow with me for my solution, and I would be more than happy to look into your solutions and suggestions in the comment section. So Let's go there. If we have a close look at our tags that we have used so far in our startup sequence, we have created 3 tags for our discrete outputs: auxiliary, main, oil. All of them are Boolean data types. We have start and stop. Both are Boolean data types for the inputs, and we have T1 and T2, both timers for our startup sequence. So just to stay in the sequence, let's create 2 more tags, T3 and T4. Okay, we cannot create 2 tags with the same name, of course. Thank you, Mr. Software. And of course, if you look, T3 and T4, even though we are using the same name convention with the T1 and T2, however, this does not make them timers. The only way to make or to identify these tags as timers is by going to the data types and changing them to timers. What's missing? We still have the shutdown, so let's go ahead and create that one. And finally, I'm going to create this tag. I will explain to you in a minute why I'm going to be using this as well. So I'm going to give it a name, iShut. Okay, so right now we have a list of our tags. I believe that's all what we need in order to start building the coding or the logic for the shutdown sequence. But before we move forward and build the necessary instructions, let's have another look over here. So over here in my list of tags, I'm keeping things as clean and neat as possible. Okay, however, what you need to do or understand over here is that for all the discrete outputs and discrete inputs, the start, stop, and the shutdown, in your actual code, they will have an actual addresses tied to them over here. Okay, so local to output, and then you set data, and then you choose the bits that are to which these actual inputs and outputs connect to. Okay, however, over here I'm just keeping things as clean and neat as possible. That's why I'm not showing you or revealing these addresses. However, for the iShut will not have any address in this field over here because it's internal. Internal means that it does not connect to actual input or output, and we will see how to utilize this in our solution. Let's see. Okay, so the first thing we need to add in our program is a new rung, and in this new rung we are going to have this kind of structure. So we have the shutdown, okay, which is an actual input. This is going to trigger the iShut that we have, the iShut, which is internal tag, and we are going to latch it over here. So the shutdown will trigger iShut, and I need to use this internal tag in rung number 2 in order to turn the auxiliary motor off. So how can I do this? iShut by default it's 0. Once triggered by the shutdown, this will go to 1, and that's when I need this auxiliary motor to go to 0. So this is going to 1, this goes to 0. It means I need to add an XIO, which acts as an inverter because of the relationship that we have between iShut and auxiliary motor. So we want iShut when it goes to 1, I need auxiliary to go to 0. That's why we are going to use an XIO. So pretty simple. And do I need to add the necessary instructions that will take care how to turn off main motor and oil motor? The answer is yes. However, I will not do this. As I told you before, every time you add the necessary requirement that or necessary code that fulfills one requirement, let's go ahead, download, and see if what we have added, number 1, did not mess anything that we have solved before. Number 2, it fulfills that specific requirement. So right now we are making sure that this rung is rung number 3, and this instruction in rung number 2, all of these will take care of the requirement that told us that we need to turn off auxiliary motor right away once shutdown is pressed. So I will download this right now and fix the watch list, and then we will do the necessary testing for the shutdown and auxiliary motor. So give me a minute. So right now we have our program in run mode, and to the left side I have a quick watch list through which I'm going to run this program. So to start with, and we are going to hit the start. The whole startup sequence is running, and I need to make sure that this code that I have added so far, rung number 3 and this instruction, did not actually mess up my startup sequence, right? So oil motor, main motor, and finally auxiliary motor, all of them are on right now. And if you look right now on rung number 3, I'm going to activate the shutdown. So the shutdown is normally open, so it goes from 0 to 1, right? And you see what this happened? The iShut is triggered right now, and auxiliary motor turned off right away. Okay. As you can see, main motor and oil motor are still on. Any guess why are they still on? Okay, I'll give you 2 seconds. Okay, if you found it, that's great. If you didn't find it, that's fine. The reason they're still on is because we have not yet integrated their solutions for the shutdown sequence. That's why they're still on right now, even though we have an actual shutdown over here. But this shutdown only took care of turning off the auxiliary motor. It did not yet expand its role in order to turn off the main motor and oil motor. So this is our next step. However, one final remark before we move forward is the following. A very common mistake in these type of problems, when you are having like a startup sequence and shutdown sequence, a very common mistake people would do is, since we have finished the startup sequence, once they start building the necessary instructions or code for the shutdown sequence, is they add new rungs for the auxiliary motor in the shutdown sequence, and another rung for main motor in the shutdown sequence, and oil motor, a new rung for the shutdown sequence. So technically they end up adding new rungs, and this will cause some errors or warnings to be in our program. Remember, even though we are adding startup and shutdown sequence in our program, but still all of these are for the same outputs. That's why we do not need, I repeat, we do not need to add any new rungs for these outputs. Since I already have these outputs and I have the necessary rungs for these outputs, all what we need to do is add the necessary instructions among these rungs that will take care of the shutdown sequence. Okay, so right now let's expand this role and see the necessary code that is going to take care of turning off the main motor. So let's go there. Shut. Why did we use this in rung number 2? In other words, why couldn't we use over here the shutdown input instead of this internal bit? Why didn't we use this? Okay, so to answer this question, all what I will do right now is download what we have built so far and see if this arrangement, all what I did right now is in rung number 2, I replaced the XIO that used to refer to iShut, and instead I used the actual input shutdown over here. Okay, and let's see how the program runs and see if this slight modification affects our solution, yes or no. The download is complete, and as you can see, all motors are on. Oil motor, main motor, and auxiliary motor, all of them are on right now. So what's going to happen once you press the shutdown? Remember, shutdown is given to us as normally open momentary switch. So please focus on the concept. It's momentary switch, and because it's open, if unpressed, what will happen when it's pressed? It will go from open to close, and this will read from this will reflect a change in the PLC memory going from 0 to 1. So the shutdown is pressed, it reads 1 over here, and look at rung number 2. Over here, this XIO referred to shutdown is false. It broke the rung, and the auxiliary is off right now. So up to this moment, if we go ahead and delete rung number 3, this looks fine so far. But look at the glitch over here. Remember, shutdown is what? It's normally open momentary switch, and what momentary means is that at some point you will let go this push button, and once you let go, it will go back to the default state, which is the open state, and this reflects in the PLC memory going from 1 to 0. And look back at rung number 2, what will happen? This goes back to true, and because we haven't done anything to timer 2, this rung number 2 is back on, and auxiliary motor is on again, without having to go through the whole startup sequence. Okay, and that's why do you see the importance of integrating this iShut, which is an internal bit? So iShut is an internal bit, internal memory location inside the PLC. It's not tied through an address to any input or output. However, this shutdown is triggering it, and when it's triggered, it's going to permanently break this rung by turning this instruction to false and continuously keeping auxiliary motor off. And that's why the iShut is important. Okay, so right now I'm going to go ahead and add the necessary code and rung that will expand the role of the shutdown to turn the main motor off after the auxiliary motor is off by 10 seconds. Let's build that.
Now that the iShut internal bit is taking care to turn off auxiliary motor once shutdown has been pressed, we need to look at the second step of the shutdown sequence. And folks, before we proceed and add the necessary instructions to fulfill this requirement, let me bring one thing to your attention that I came across a few days ago in one of my personal tutorings. The guy asked me, I have a problem to specify how and where to start a solution on a problem level or even a simple and single requirement level. That's when it hit me that this simple question not only is extremely important, but it repeats itself multiple times in every single problem. For this, let us agree on developing a small technique I like to call dissect each requirement and specify the IOs involved in it and the relationship between them. So, for each requirement we are addressing, we need to specify the outputs involved, the inputs affecting them, and the relationship between the inputs and the outputs. Is the input energizing the output? Is it de-energizing it? And what is the relationship between them? Is there any timer factor between them, or counter factor, or any other factor that connects the two? Now, we will use this technique, dissect and specify the IO, to add the necessary instructions for the second step of the shutdown sequence. The second step of the shutdown sequence states, after shutdown has been pressed, the main motor is to turn off after 10 seconds. So let's follow this technique. The output involved. I like always to go with the output and go backwards to the input, but it works anyway. So what's the output involved in this requirement? The output is main motor. It exists in rung number 1. What's the input involved in this specific requirement? It's shutdown. We have it in rung number 3. And what's the relationship between them? Is it an instantaneous relationship? So hitting shutdown, turn off main motor right away, instantaneously. Or in this case, it says after 10 seconds. So 10 seconds after shutdown has been pressed, the main motor is to turn off. So what do we get off from this dissection, from these specifications, specifying the input or inputs, the output or outputs involved, and the relationship? In this case, there's a timer factor involved. The first thing is, what is the output? It's main motor. We need to ask ourselves, do we already have a rung with main motor as an output in it? The answer is yes, it's rung number 1. Even though this sounds, silly or simple, but it's really important, because in a big application, you might come across multiple requirements for the same output that you have targeted before. So if you already have a rung with the output of interest, like in this case, the main motor, it's already exists, this is telling us that we do not need, actually it's wrong, to create another rung with the same output in it. Whatever instruction or instructions we need to add to fulfill this specific requirement that we are addressing right now needs to be added within this rung. Like in this case, it's rung number 1. Does that make sense? Second of all, the relationship between the input, in this case the shutdown, and the output, which is the main motor. Shutdown exists in rung number 3 in this case, or in one of the rungs, in this case number 3, and main motor is rung number 1. There is a timer factor, remember, 10 seconds after shutdown is pressed, the main motor is to turn off. So it's not an instantaneous relationship. We need to get to this flow of events. Shutdown pressed, goes all the way to the timer. The timer needs to be triggered. For how long? For 10 seconds. Once the timer has passed or run for 10 seconds, we need to use one of the elements of that timer to turn off the main motor. Okay, so only by getting this flow of events will help us identify which rungs we need to modify, also which instructions we need to insert in each one of these rungs. So let's start with the first flow of events. Shutdown is pressed, a timer T3 needs to be triggered. So far we have only used T1 and T2, so it makes sense to go with T3 in the upcoming timer right now. Now there is no T3 yet. We can add a new rung for this one, but because we already have a rung with iShut that's triggered by shutdown, and the flow of events is telling us that this new timer will be triggered by shutdown, so we can save some rungs and create a parallel branch across the iShut and use it to insert the timer in it. Parallel branch, drag all the way to the opposite side, and right now you can insert the timer. We already created tags for these, so T3, preset value is for 10 seconds, and the accumulator always starts from a 0. Does it make sense? So the first flow of event shutdown is triggering the timer. Timer will run for 10 seconds. Which element of this timer tells us or acts as a flag for us, telling us that 10 seconds has passed since the timer has been triggered. Remember, three main elements of the timer: enable bit, timer timing, and done bit. Some basic analysis tells us the done bit is what we need to use, telling us that 10 seconds has passed after shutdown has been pressed. Remember, after 10 seconds, our target is this output, main motor, with the help of the done bit of this timer. So the done bit of this timer will act as stop for the main motor. So what we need to do is we need to add either an XIC or XIO, because the done bit is nothing but a discrete bit. So we need a discrete instruction with it, XIC or XIO. Which one to use? Let's see. We need, when the done bit goes to 1, energized, we need the main motor to go to 0, de-energized. Does it make sense? Because it's acting as a stop. Because we are having this inverse relationship, it means we need to go with the examine of off, XIO. Okay? And for this one, it's T3, which is the timer name, dot done, which is the element or specific element of that timer. Okay, let's see. Shutdown pressed. iShut will be triggered and it will turn off auxiliary right away. We have already tested this, and the latching across the input will make sure that the timer is on all the time. After 10 seconds, this guy will be off or false. It breaks the rung, and supposedly main motor needs to be turned off at that point. So before we proceed and add the necessary rung for the oil motor, we need to download what we have built so far. Make sure that the second step of the shutdown sequence is fulfilled, and whatever success we have achieved so far is not ruined. Okay, so I'm going to download this, and then we're going to test if it works as anticipated. Download is complete, and I already initiated the startup sequence, because we cannot proceed and test the shutdown sequence unless the startup sequence is fully complete and all three motors are already on. As you can see on the screen right now, oil motor is on, main motor is on, and auxiliary motor is on. Pressing shutdown will turn off auxiliary right away. 10 seconds later, main motor needs to turn off. Let's see if the logic that we have built so far is acting like this. So pressing the shutdown will make it go from open to close, 0 to 1. The iShut is on right now, auxiliary right away is turned off. T3 is running for the full course of the 10 seconds. Right now, main motor is on. Once T3 hits 10 seconds, the done bit goes to 1. The done bit referred to with the XIO goes to false, breaks the rung of main motor, and main motor turns off. Okay, so this part is working fine. Right now we have two parts of the shutdown sequence are working fine. So what we need to do right now, we need to extend our logic so that once main motor is off, we want the oil motor to turn off 5 seconds after main motor is off. And to do this, we need to go with the same logic, the same technique that we have done. So the flow of events goes this way. When timer 3 is done, we want to trigger another timer T4 for 5 seconds, And once that timer is done, T4 is done, we want to use its done bit to turn off the oil motor. Make sense? So we need to add another rung over here. We're still in the run mode. So new rung. In this new rung, we are going to have T3.done. It's triggering T4. So this is the first part of the flow of events for 5 seconds. Okay. And once the done bit, once T4 hits the 5 seconds, we want to use its done bit, the done bit of T4, that will act as a stop for the oil motor. Okay. So the same logic, same choice of instructions. This is T4.done. Remember, T4.done goes to 1. I want oil motor to go to 0. Inverse relationship means we are going to go with an XIO to refer to it. So, as always, we need to download what we have so far and test our logic if it's working as anticipated. Download is complete. Startup sequence is complete. You can see all 3 motors are on, showing green colors. To the left side in the watch list, you can see all of them reading 1 in the PLC memory. Since all of them are on, we can go ahead and test right now the full shutdown sequence once shutdown is pressed. So it goes from 0 to 1 in the PLC memory. Immediately auxiliary goes off. T3 is on for the full course of 10 seconds. If you keep an eye on the main motor is still on for 1 more second and then it turns off. Right now, T4 is running for 5 seconds. Once it's done, the oil motor will turn off. So what we have built so far, our program is running perfectly in terms of building or running the full startup sequence and shutdown sequence. What we need to test right now is the capability of our program to run all over again. In other words, our program will not work for one time only. So after the shutdown sequence is completed, if we decide to go for a new cycle of startup and shutdown again, we need to be able to do so simply by pressing the start. If it works fine, the full startup sequence, then we're okay. If it doesn't work, it means there's a problem in our program or a glitch somewhere, and we need to enjoy looking and searching for it. So let's see right now. I haven't done anything. After we finish the shutdown sequence, let's try if we press the start. What's going to happen? If the program is running properly, the oil motor needs to turn on and T1 needs to run for 10 seconds so that it drives main motor and so on after the auxiliary motor. Do you see any of this happening? Okay, with a simple eye, no, it's not happening. It means there is something wrong in our program. I will not say it's a big mistake, but there is a glitch that exists somewhere. And what we need to do is enjoy looking and searching for it. So I'll give you the time for you to look for where the glitch is. I'll only give you the hint. The hint is in rung number 0. As you can see right now, even though start is momentary switch, I'm mimicking as if I'm pressing and holding it. Even with this, the oil motor is not turning on. So where is the glitch? I'll leave you for to enjoy the journey to look for it. Any good news about the glitch? I'm sure that many of you have figured it out, and I appreciate if you can share with all of us in the comment section what you have figured out. If you haven't, even better, consider this as a practice to fix a program that was not created by you, but now you are in charge of modifying it to fulfill a new task. If after you try you cannot figure what's the problem, don't worry, share your thoughts and trials with us in the comment section and we can discuss what you have thought. Now, getting back to the main request to initiate the shutdown sequence, it said only when all 3 motors are on, pressing the shutdown will initiate the shutdown sequence. In other words, if we press the shutdown while auxiliary motor, as it's the third and the final motor in the 3-step of the startup sequence, is already off, this should not, I repeat, should not initiate the shutdown sequence. Let's see if what we have built so far fulfills this requirement. So what I'm going to do right now is I'm going to press the start. Let go, the oil motor is on and the timer 1 is on. Main motor is still on, waiting for T1. In the meantime, I'm going to press shutdown. Okay, so you see shutdown is pressed. The internal bit iShut is on right now. What happened to the auxiliary motor? Did you guys focus over here? I pressed the shutdown even before the auxiliary motor was on. What happened is it initiated the shutdown sequence before the startup was fully completed. It means what we have built so far is not quite fulfilling that main task. If we press shutdown while not all three motors are on, nothing should happen. The only way for the shutdown to be effective is by pressing the shutdown and at the same time all of the three motors are on. So what we need to do, we need to add a simple instruction that's going to fulfill this task. And again, if we go with the same technique that we have said before, what is the flow of events that we are tracking over here? We want, if shutdown is pressed while auxiliary motor is off, nothing should happen, right? So it means we need to modify rung number 3 with an extra instruction or extra condition that's going to make sure if shutdown is pressed while auxiliary motor is still off, the iShut will not be energized and the whole shutdown sequence won't be initiated. I'll give you folks a minute to think it over, or simply you can pause the video and see what instruction needs to be added and where it should be added. Do you have a solution of your own? You should have a solution of your own. But right now, I'm going to present my solution, and I do expect that we can compare our solutions together. So if you think your solution is better or covers more factors or aspects, please do not hesitate to write this down in the comments section. So, in which rung we need to do our modifications? In rung number 3. Why is that? Because this specific requirement is telling us that we need to prevent the initiation of the shutdown sequence if auxiliary motor is not turned on, right? So what do we need to do? We need to add one instruction in series with the shutdown in rung number 3, and this one refers to auxiliary motor. Simple instruction. Remember, I'm using the auxiliary motor because auxiliary motor is the last motor in the sequence of motors in the startup sequence. So that's the only modification that I did over here. So before I download the program and do the running, let's do the analysis together. So if we press shutdown, this instruction turns green, right? Over here. But as long as auxiliary is off, this will remain off. So we won't have any logic continuity across this rung, and the iShut will not be triggered. Does that make sense? Let's download and see if our analysis is actually correct. For the last time, the download is complete, and right now we are going to test if we press shutdown before the startup sequence is fully completed, if it's going to initiate or no. So let's go ahead by pressing the start. The startup sequence has started. Please focus on rung number 3. I'm going to press the shutdown. As you can see, the shutdown is pressed, okay, but the iShut did not trigger, and this is why, because the auxiliary motor is off. Right now, pressing the shutdown did not initiate the shutdown sequence. Only when all three motors are on, and how do we know this? All of them are green, and we use the auxiliary in series with the shutdown because it's the last motor in the startup sequence. Right now, if we press the shutdown, that's when the iShut is triggered and the shutdown sequence has started. By immediately auxiliary goes off. After 10 seconds, the main motor goes off, and after 5 seconds, the oil motor is off. Okay, so right now, simply by adding this instruction in series to the shutdown, made sure that the shutdown sequence cannot initiate unless all three motors are on. So before we end this, any guess about the glitch? If some of you did not get the glitch yet, so this is your chance. In rung number 0, if I press the start, I'm holding it. Why is the oil motor not turning on? Just focus on this rung. There is a gap in this rung that's not allowing us to start oil motor all over, and that's our glitch. So think of this, and Whatever you think and you come up with, write down in the comment section. See you in the next video.